Next part in this chapter, plane. You already know about a plane. Surface of board, it is a plane. Surface of wall is a plane. Sheet of paper is a plane. Plane, it is two-dimensional figure. If any 2 points lie on a plane, then line passing through them totally lies in that plane. Two intersecting lines, they form a plane. Two parallel lines, they also form a plane. One line and one point which is outside that line, they also form a plane. Three non-collinear points, they also form a plane. If 3 points they are collinear, then they do not form a plane. They can form a line only. Because points are collinear, then line passes through them. Now equations of planes, they can be written in different forms. Similar to line, equations of planes, they can be written in vector form as well as Cartesian form. Equation of line in normal form. If we know vector normal to plane, line normal to plane means it is a line which is perpendicular to that plane. If line is normal perpendicular to the plane, then that line is perpendicular from any point in this plane. Conversely, if any line is perpendicular to one of the lines in a plane, then that line, it is normal perpendicular to plane. Means a line which is perpendicular to plane, it is perpendicular to each and every line in that plane. If we know vector, that is unit vector normal to the plane, unit vector normal to plane usually denoted by n cap. So if we know unit vector normal to plane and perpendicular distance of plane from origin, then we can write equation of plane in vector form. Suppose perpendicular distance of plane from origin is P and n cap, it is unit vector perpendicular to plane, then we have to write equation of plane in normal form. Consider three-dimensional geometry. Three axes which are mutually perpendicular to each other. Point of concurrence of three axes is origin. All the three mutually perpendicular axes, they pass through origin. Perpendicular distance of plane from origin P. This is perpendicular from origin, perpendicular to the plane. Suppose it cuts plane at point N. So N is a point in the plane. Distance of perpendicular distance of plane from origin P, and N cap, it is a vector normal to the plane. ON, let us consider vector along this line. Vector directed from origin towards point N. Usually position vector of point, it is denoted by small letter. So we shall denote it by N bar. O N bar equal to N bar. Let us consider any other point on the plane other than N. Suppose R is a point in the plane with position vector R bar. R is a point in the plane. Its position vector means vector directed from origin towards point R, OR bar. Usually position vector of point denoted by small letter R bar. Join NR. NR bar, it is a vector in that plane because N and R, these are the 2 points in the plane. Vector passing through 2 points or line passing through 2 points in a plane also lies in that plane. It means that vector NR bar lies in the plane. Now ON, it is perpendicular to plane. It means that N bar, it is perpendicular to the plane, or N cap, it is along N bar. N cap is nothing but unit vector. Now we know when A bar is a vector, then its magnitude denoted by mod A bar. Unit vector along A bar denoted by A cap. And A cap is defined as A bar upon magnitude of A bar. So unit vector, it is defined as vector divided by its magnitude. Here N cap, unit vector along N bar. So N cap equal to N bar divided by magnitude of N bar. And here magnitude of N bar equal to P, because length of directed line segment is magnitude of vector. ON, that is equal to P. And magnitude of ON bar, it is same as magnitude of N bar, and that is equal to P. So N cap equal to N bar upon P. So here N bar equal to P N cap. Now, nr bar, vector in space, it is directed from point n towards point r. N is initial point, r is terminal point. And vector in space can be expressed as position vector of terminal point minus position vector of initial point. O r bar minus O n bar. Usually position vector of point denoted by small letter. So here O r bar equal to r bar minus O n bar equal to n bar. Now, vector nr bar perpendicular to n cap. N cap, it is vector normal perpendicular to plane. Nr bar, it is a vector in plane. And any vector which is perpendicular to plane, it is perpendicular to every vector in that plane. As two vectors are perpendicular, their dot product is 0. So n r bar dot n cap equal to 0. N r bar minus n bar dot n cap equal to 0. Open the bracket. R bar dot n cap minus n bar dot n cap equal to 0. Here we have to open the bracket. R bar dot n cap equal to n bar dot n cap. Now n bar equal to p n cap. So LHS as it is. R bar dot n cap equal to p n cap dot n cap. N cap dot n cap, dot product of two vectors. It is square of vector quantity. So p into n cap square. Now we know square of vector and square of magnitude of vector same. A bar square same as magnitude of a bar square. So p into magnitude of n cap square. And n cap is a unit vector. Magnitude of unit vector is 1. So p into 1 square. Since magnitude of n cap equal to 1. So r bar dot n cap equal to p. If we know unit vector normal to plane and perpendicular distance of plane from origin, then we can write equation of plane in vector form. Here n cap is a unit vector normal to plane p. It is perpendicular distance of plane from origin. Now equation of plane can be written in Cartesian form also. If L, M, N are direction cosines of normal to plane. Normal to plane means perpendicular to plane. And if we know coordinates of point, any one point in the plane, suppose x, y, z, coordinates of any point in plane, p is perpendicular distance of plane from origin, then we get Lx plus My plus Nz equal to P. This is equation of plane in Cartesian form. For getting equation of plane in Cartesian form, what we should know is direction cosines of normal to the plane and perpendicular distance of point from the plane.